In this video, we're going to be looking at section 3.5, the 5-number summary and box plots. So this one's going to be relatively quickly, but we're going to compute what we call the 5-number summary and then draw and interpret box plots. You've probably seen this before, so it shouldn't be too laborious. So when we talk about the 5-number summary, so just recall that the median is a measure of central tendency that divides the lower 50% of the data from the upper 50%, and it is resistant to extreme values and is the preferred measure of central tendency when we're skewed right or skewed left. The 3 measures of dispersion that we talked about in 3.2, which are the range, the standard deviation, the variance, are not resistant to these extreme values. However, when we talked about the interquartile range, which was the 3rd quartile minus the 1st quartile, which is the difference between the 75th and the 25th percentile, that is resistant. And again, it's interpreted as, so the interquartile range is interpreted as the range of the middle 50% of your data. Okay. However, the median, quartile 1 and quartile 3 do not provide information about these extremes in our data, the very small and the very large. So the 5-number summary of a data set consists of the smallest data value, then the 1st quartile, then the median, the 3rd quartile, and then the largest. So we call that the minimum, quartile 1, the median, quartile 3, and then the maximum. And those 5 numbers are what we call the 5-number summary. Okay, so if we take a look in this picture right here, okay, you can see in the 5-number summary so we've got a minimum, then quartile 1, then the median, then quartile 3, and then the maximum. And you can see that the distribution here is very skewed to the right. And so with it being very skewed to the right, then that's going to be pulling the mean. So with our 5-number summary, we can make what we call a box plot. Okay, so in this box plot, what we can notice on a skewed right distribution is that we've got this tail heading out to the right here, and so that's where potentially we could have an outlier. So we see this longer pull in what we call our box plot. So in our box plot, so you'd have the minimum here, then this line represents Q1, then the middle in the box represents the median, and then Q3, and then this represents the max here. And the box, the width of the box is the interquartile range. So if you see a bigger box, then that means you have more spread. If you see a smaller box, you have a little bit less spread. If you're symmetric, so this data is relatively symmetric, then you're going to see these 2 little, sometimes you call them whiskers, that are almost identical in length. You can see the median is kind of right in the middle of the box. And then when I'm skewed to the left, you can see that I've got this big whisker, or this big tail on the left. And also the median is going to get pushed a little bit farther out from that tail. So that's just a look at how you would compare skewed right, symmetric, and skewed left from a histogram standpoint to a box and whisker. Again, the box and whisker are very straightforward, just a minimum, quartile 1, median, quartile 3, and a maximum. And they all have kind of their own general points here that we grab. So each of these little points here. Okay, so now we're going to use these 2 distributions, X and Y, these box plots, to answer some questions. So you might want to take a minute, pause, and say, okay, X, is that skewed left, skewed right, symmetric? And then the same questions with the variable Y as you look at those. So the first question, A, says, to the nearest integer, what's the median of variable X? Okay, so variable x, try and draw the best straight line I can. It looks like that median, again, median is the line right down the middle of the box. It looks like it's right at 40, so it looks like the median there is 40. Then what's the third quartile of variable y? So now I'm down here in variable y. Third quartile is this outer line. I'm trying to go straight. I'll call that 52 for quartile 3 there. Okay, which variable has more dispersion? Well, if you look at the inner quartile range of y, it is much, much bigger than x. And so in this case, we would want to say, and we could say with some pretty good confidence that y has more dispersion because it's got a larger inner quartile range, and also just the range in general. We're going all the way out here from about 111, 112 down to almost 0, whereas we're much tighter up here in x from our minimum to our maximum. Okay, now in part D, we want to describe the shapes. So hopefully you took a moment to look at that, but x definitely looks to be approximately symmetric because those whiskers on the box, or tails, however you want to look at them, relatively similar in size. And that median is pretty close to being dead center on the box there in our inner quartile range, so that would be symmetric. Now y, notice that we've got this bigger whisker or tail out to the right hand side. Then the median is a little bit to the left in the box, but that tail is headed out right, so that's going to tell us that we are skewed right. Okay, and so that's how we can make some, we can get some understanding about the distribution by looking just at the box plot. Okay, so if you were to draw a box plot, here's kind of the route you're going to take. Okay, first you want to determine the upper and lower fences. Okay, again, those were Q1 minus 1.5 times inner quartile range, and then Q3 plus 1 or minus, or excuse me, plus 1.5 the inner quartile range. Because sometimes we'll choose to draw the box plot without including the outliers. For example, if there were big outliers, you might see just a couple of dots out here, or one dot, or however many, because those really, really skew the data. So sometimes you might be asked to draw it without the outlier. So identifying those first can be helpful. Okay, next you're going to draw a line long enough that includes the max and the min. So you're going to draw basically this line right here first, going from max to min. Okay. And then, oh, I didn't even finish that. Then you're going to insert lines for Q1, the median, and Q3. So those are these 3 lines right here, if you can see my highlighting. Those 3 vertical lines. Okay, then sometimes you'll label your upper and lower fences. Again, it just depends on if you're asked to include outliers or not. Okay, and then we draw a line from Q1 to the smallest data value that is larger than the lower fence. Draw a line from Q3 to the largest data value that is smaller than the upper fence, and these are what we call the whiskers. Okay, again, that's just these guys right here. And then any data values that are lower than your lower fence or greater than your upper fence are outliers, and you mark them with an asterisk. But it just depends on if you're asked to do that or not. And I'll show you in StatCrunch what that looks like. Okay, but we are going to use StatCrunch to do these. They look a lot better, and they can help us out quite easily. So we've got the age and inauguration for presidents, and this is up through Barack Obama, and we want to find the 5-number summary, create or construct a box plot, and then comment on the shape. So I've got all my data here in StatCrunch, and I'm going to go graph, box plot. I'm going to grab the age of the president. I want to draw the boxes horizontally. If not, it's going to, I'll show you the difference here. So it's going to put it vertically unless I click this number. But you can see right here that it actually has an outlier. So we've got one outlier here at age 69. And so in StatCrunch, the reason why it's showing that is because I have checked this one, use fences to identify outliers. If I uncheck that, then notice that point goes away and I get a little bit larger. So it just depends on what we're asking. But in this case, in the text, it's going to ask you to use those fences. So we'll just put that information right there. So then we can actually get our 5-number summary. If I hover over this, you can see all of those numbers. So you can see, I can't really move my mouse to highlight them, but you can see the number of values. The number of outliers is 1, the IQR is 7, the lower limit's 42, the the quartile 1 is 50.5, the median is 54.5, then we're 57.5 for Q3, and the upper limit is 68. So, so if you were to draw this thing, if you were asked to draw it by hand, let's do a quick little rough sketch here. Those are supposed to be arrows, but I'll call this 40, 45, 50, 55, 60, 65, and then 70. So again, that minimum was at 42, so I would draw a little line there for 42, and then the maximum there was, if I draw it without the outlier, it would be at 69, but if I draw it with the outlier, it's going to be at 68, and then I'm going to connect those two. So that's my range. And then I'm going to draw a vertical line for Q1, which is 50.5, so about right there. And then Q2, 54.5. I'll draw another vertical line. Q3 is 57.5. Oops. And then I'm going to just create my little box here. Well, it's the best box we got. But so that would be how we draw this. Now, when we look at this, and I'll go back over to StatCrunch so you can see the box. If I look at this, it's hard to tell if this is, I mean, there could be a little bit of skew to the rightness going on here. But for me, when I look at it, I see more symmetric than being skewed, because there's nothing that really jumps out as being super skewed. So we're going to call this one symmetric, based off of the distribution and the box plot. But of course that could be up for argument. Oh, and then you have your little asterisks right here for your one outlier. So I hope that helps out. That's it for box plots. If you got questions, let me know, but hopefully this one's nice and straightforward for you.